Hello talkers, and welcome to this talk from Cornelia Davis at Weaveworks on the topic of GitOps and why it is likely more than you think it is. She talks benefits, use cases, as well as shows us some demos, so I'm really excited to dive into this talk from KubeCon and Cloud Native Con Europe.
Good morning, good afternoon, or good evening, wherever you happen to be joining me from. I'm so delighted you're here. We are going to spend the next 35 minutes or so talking about GitOps. I'm betting that most of you have some idea of what GitOps is, but I'm betting that there's more to it than you might be thinking about. And that's what I want to show you in the next half hour or so. By way of a brief introduction, my name is Cornelia Davis. I'm the CTO at Weaveworks. I've been in this industry for a long time, about 30 years. My background is in development. I've always been a developer. There's a little hint there that says wasn't ops, but I can definitely consider myself an ops person now as well. Been working in web architecture, for well over 15 years, cloud native for nearly a decade, although I'll definitely concede to you that we didn't always call it cloud native. We certainly didn't call it cloud native a decade ago. A lot of that experience comes from a long time working with Cloud Foundry, which was a cloud native application platform that's been out there for quite some time. I've been doing Kubernetes for nearly 4 years, which doesn't make me a veteran, but it doesn't make me a total noob either. The other thing that I mentioned is that I'm the author of a book called Cloud Native Patterns, which is targeted at the application developer and architect, and goes over all of the patterns that are required to make software work really well in the cloud, being software that works well in a highly distributed environment that is experiencing constant change. Now, that notion of cloud native is very relevant to the GitOps area, but rather than focusing on the development of software, the software patterns themselves, what I want to do with GitOps is talk about cloud native from an operational perspective. So come along. So I'm not going to spend a lot of time going into the details of the benefits that come from GitOps. We will talk about a few of those things as we go along, but there are GitOps, we're not doing GitOps for GitOps' sake. There are certain benefits that we want to realize. And those benefits really center around things like security, repeatability, recovery from failure, productivity gains so that we can do things over and over, reducing toil, all of those types of things. And the way that we do GitOps is going to have a direct impact on the benefits that we get to enjoy. Now, GitOps is, if you will, a set of practices and patterns, and then of course tools that help you implement those practices and patterns that really give you that DevOps environment that has come to dominate the way that we think about delivering digital assets these days. So given that we want to achieve certain benefits, the question then is, how do you GitOps? What is GitOps and how do we do it? Now, I'm betting that most of you have an impression of GitOps that goes something like this. We're going to store code and increasingly configuration in something like Git. After all, Git is the first part of the name GitOps. Doing things in Git is going to cause some automation to happen, and that automation is going to configure some type of a runtime environment. Now, GitOps, of course, is applicable to both applications that are running in that runtime environment, but you'll see as we go along that it's also very applicable to the configuration of that runtime environment and the standing up and maintenance of that runtime environment as well. Oh, and of course, one of the whole points of GitOps is that the primary user interface for this GitOps process is all the way back on the left-hand side of this diagram on the Git side. So the UX is actually using Git. Now, that doesn't preclude other user experiences, but Git is one of the significant ways that we can interact with this GitOps environment. So rather than humans touching the right-hand side of the slide, we're touching the left-hand side. So this is, if you will, the 10,000-foot view of GitOps. And is this indeed what GitOps is? And the answer is yes, but details do matter. And how we actually put those pieces together, and most notably, how we do the automation that is in the center of that diagram, that is going to have a direct impact on the level of benefits that we enjoy coming from our GitOps practices. Now, I have a confession to make. I have been known to call myself a propeller head before, and I am a technologist. And what we're going to do in the next 30 minutes or so is I'm not going to present to you the principles of GitOps. We're going to derive them. So yes, I'm a mathematician at heart, and in mathematics, we do derivations. But if you're not a mathematician, please stick with me, because I think you'll enjoy this even if we don't, do proofs at that level. So I'm going to kick things off by going back to a version of this diagram that we just saw a moment ago. It's perhaps a little bit more detailed, but it does launch us on our journey of this derivation. So this is a pattern that I'm sure most of you are familiar with. We've got the developer and the DevOps engineer. They might be the same person. They might be two different individuals. And they're checking their code, their source code, into a repository. They've well-established CI practices that are these days, because we're operating in a containerized environment, generating those container images. Increasingly, we're also storing the application configuration in Git. And then, as we alluded to in the previous slide, we're going to use some automation to draw those pieces together and get them running in some type of a runtime environment. And this is KubeCon, so of course we're going to talk about that runtime environment being Kubernetes. Now, if we take a look at this and we think about that automation, how do we achieve that automation that I'm alluding to that's right in the middle there? Well, we've already got some automation in this picture, right? Well understood and well-established automation, and that is the CI system. So in fact, that might be the first place that we might look, is to say, well, can I just add to that CI process? I mean, after all, continuous integration is extremely well understood. We've been innovating in that space and maturing that, and we have a deep understanding of it. It's been more than a decade, probably closer to 2 decades, where we've been putting some type of continuous integration processes in place. And we've achieved all sorts of benefits, from higher quality and shorter time and repeatability and the reduction of toil and developer productivity and all of that. So it would be natural for us to think, all right, well, let's go ahead and just insert deployment as a part of that automation. But I'm going to argue to you that continuous integration is not the same as continuous delivery and deployment, that there are reasons to separate those out. And those reasons include things like, if you are running in a regulated environment, you know that you are dealing with separation of concerns. Developers release code. They are the ones that write the code and release it. But then operators do the deployment. They've got the keys to the production environment. They've got a set of rigorous processes that they're trained, that are intentionally not given to the developers. Again, because the separation of concerns ensures certain levels of security that are difficult to achieve in other ways. Another thing is that you're very likely to take that artifact that you're creating in your continuous integration process, and you're going to deploy it to many different environments. So there's already kind of an inherent need for the decoupling so that we can go to those different environments. And another reason for having decoupling is to be able to recreate a deployment that shouldn't, and that because we've had some type of a failure, for example, and that shouldn't require a new build to be created. So those are some of the reasons why we want to decouple these things. So rather than having this picture, what we want to do is we want to draw that deployment back out of continuous integration. So one of the things I'm very fond of saying is that there's no CI/CD. It's not one word. There's CI and there's CD, but there's absolute benefit in separating those. And that's what we see in this picture. So we no longer have it in the CI process. Now, that CD process is great. And one of the benefits that I didn't mention on the previous slide is that if you are including deployment as a part of your CI process, that generally means that your CI process is being given the keys to that environment, that deployment environment. So you've got the keys or you've got the credentials, those types of things, which represents a security boundary. Even if you're not worried about the developers, just having that system, the CI system now is an attack surface. And that is not at all uncommon for us to hear those stories where a breach happened because somebody was able to make it into the CI environment and through that get into the runtime environment. But beyond that, so now we say, okay, well, the credentials aren't in the CI system and we can constrain those to being in the CD system. We can say that the operators are the ones that are running the CD system. So we've got the separation of concerns. But what happens if we now have this? I'm doing that deployment to a bunch of different environments, dev, staging, and prod. Now I'm back to needing the keys to dev, staging, and prod, all from this kind of centralized hub and spoke CD system. So I'm back to struggling with this security concern. You can also imagine that there might be deployments where we're not talking about 3 targets. We might be talking about hundreds of factory floors. So we're starting to talk about edge deployments. Or you might have thousands of coffee shops or sandwich shops. Or you might have tens of thousands of cell towers. Yes, we're starting to see Kubernetes running in cell towers. So now, in addition to those security challenges, I've also got challenges of network connectivity. I've got challenges of scale. How many environments can the centralized system deal with, the centralized CD system? Now, there's an easy answer. There's an easy solution to this, and that is to just spin things around. What we do then is we move the CD process from being a centralized thing to being out in the runtime environments themselves. And so rather than pushing configuration out to those runtime environments, what we're going to do is pull the configuration into those runtime environments from the repositories. Now, we'll see some patterns in just a little bit on how we can manage that at scale. But before we go to those patterns, I have to ask the question, well, if we're pulling, then how do we know when we need to pull? The answer is that we don't have to. We certainly can use events. We could have something like a git push event trigger that type of reconciliation. But then what happens if the network's down when that trigger happens? You've got to deal with that. Well, the good news is that we already have a pattern that we know works in this particular scenario. We don't have to know when to reconcile, because we have reconciliation loops that run forever. And this is the core pattern that Kubernetes really brought mainstream. Now, this reconciliation pattern, I have to say, existed before Kubernetes. It existed in Cloud Foundry, for example, where we applied it to the we applied it to the running of container images. Now, those container images originally predated Docker, so it was well before OCI. And we built our own reconciliation engine in Cloud Foundry. Now, Cloud Foundry applied it to this very specific use case. No question that Kubernetes applied it more broadly. Kubernetes created this reconciliation platform, if you will, and we're going to see that play prominently through the rest of the presentation. So we've got this notion of, well, we can just, inside of these Kubernetes clusters, run these reconciliation loops that are going to constantly be drawing in the configuration from those repositories. So we have the desired state in the repository, the reconciler is watching the actual state of the system, and it's doing what it needs to do to bring those two things together. So that pattern, that basic reconciliation pattern, is extraordinarily powerful, and it enables a whole bunch of other interesting patterns. Patterns that I like to call GitOps patterns or cloud native operational patterns. So let's talk through some of those now. The first one, well, actually, this is not the first pattern. This is more like the, maybe third pattern, given that we talked about pull and we talked about reconciliation. Those are certainly two important patterns. But let's talk about this next pattern, the pattern that I call drift detection and remediation. So we've done this great GitOps process where we have put our declarative configuration in Git. We have a reconciler that is constantly drawing the latest things in from Git into the runtime environment. And somebody comes along and does a kubectl apply. This is the modern day equivalent of SSHing into a box. One of the benefits, of course, of storing configuration in Git is that Git has a version history. And so if we were to have some type of a catastrophic event and we needed to recreate our environment, well, so long as there hasn't been any drift from what we have in the declared configuration, we're golden. But again, here somebody has done the modern day equivalent of SSHing, and we have drifted from that desired state as recorded in the system. So what do? Well, that reconciler is constantly running. And now what's happened is that the actual state has diverged from the desired state, and the reconciliation loop can do some type of remediation. Now, what is the remediation that you want? Well, it can actually go back and say, you know what? I'm going to undo that change. I'm going to go back to the state that was represented in the Git repository. Or you might decide that you, in fact, want to just alert on that and you want to let somebody know that something's changed. That is your prerogative, and that's what you're going to tool into what I like to start calling a GitOps pipeline, stringing together these types of behaviors into the patterns that you need for your organization. All right, so that's one pattern. Let's talk about another one that I like to call image update automation. Now, I've made a little bit of space in this slide in the middle to show you that what we have is just a basic application deployment. We've got some YAML. It's stored in the application configuration repository. We have an image that's stored in an image registry. And of course, the YAML points to that particular image, my image version 1.0, 0.0.1. Now that CI process, somebody checks in new source code, the CI process creates a new version of that container image. And now, what do? Of course, I, as an operator, could go in and I can update that, that YAML configuration, and I can check the new version of that YAML configuration into the Git repository. And through the magic of that reconciler that I talked about in the previous examples, that will get deployed out into the runtime environment. But do I need to do that as a human by hand? The answer is no. How about we throw a reconciler in there that is constantly watching that container image registry, and it does the update in the YAML itself. It does the update in a copy of the YAML that's running within that reconciler environment. Then I can invoke another reconciler that is going to have the effect of pushing that into the Git repository. Now, it could do the commit in the push immediately, or you could decide in your GitOps pipeline that what you want to do is actually generate a pull request. That pull request goes into the repository, somebody approves it, or maybe it's automatically approved. And then what happens? Well, this is the pattern that we already know and love, is we have the reconciler that's running inside the runtime environment that pulls the latest version in and has the effect of deploying the updated version of that image. So that's another pattern. Now you might notice, hint, hint, that there's a number of reconcilers here. You're going to see where we're going with those reconcilers and how we stitch all those two things together in just a little bit. But let's talk about another pattern, and that is environment customizations. Remember, we talked about this earlier. So we talked about the fact that I have dev, staging, and prod, and they're all going to be deploying this application. And while a lot of the application deployment configuration is going to be exactly the same, there's going to be some differences across those. So how do we deal with that? Again, let me make a little space in this diagram. And I'm going to talk very briefly about customize. With a K, customize allows us to do this. It allows us to store in the application configuration, first of all, some description of some configuration that has a base. So it has some commonality. So this deployment, my deployment, is going to go into dev, staging, and prod. But then it also allows me to apply overlays on top of that, essentially overrides on some of the basic things that are in that base pattern. Now, those overrides can be handled by reconcilers. So we can actually apply these customizations as a part of our GitOps pipeline. And those reconcilers, those customized reconcilers, can operate independently in each of these different runtime environments. So doing environment customizations is also an important pattern. All right, so we had started here, and those patterns that I just described to you really are addressing this. They're saying, all right, there's a whole bunch of processes, there's a whole bunch of detail that's required in this process of taking these application configurations and these images from the image registries and composing them together into the actual declarative state that's going to be running in my runtime environment. And I like to call those set of controllers that we've just been talking about, those set of reconcilers, delivery controllers. But hang on a second. I said this is about deployment, and I don't know that delivery of configuration manifests really encompasses all of deployment. So have we achieved deployment? Well, we're getting there, but we're not quite there yet. So let's look at one more pattern. Now, if we remember, we were here. Recall that in image update automation, we had this pattern. Remember, we had reconcilers that were watching the registries and updating the references in the YAML. Then we had reconcilers that were interfacing with Git to do things like pull requests or maybe automatically committing things into the Git repository. And then, of course, we had the reconcilers that were drawing those configurations, doing the composition, like using customize, like I showed in the last example, and then drawing those into the runtime environment. Now, this is a little bit too coarse-grained. We need to get a little bit more detailed here. And that is to say that technically what we were doing was we weren't getting all the way to the running of those applications. What we were effectively doing with those reconcilers is getting to the point where we had drawn that configuration into Kubernetes, into etcd. So now we've landed that in etcd. The next step, of course, to get all the way to runtime is that we have running pods in the end. Now, how did we get those running pods? Well, you might say, that's Kubernetes. And of course it is. But how does Kubernetes do it? It does it with reconcilers, right? It has a reconciler for the deployment. It has a reconciler for replica sets. It has a deployment, a reconciler for daemon sets, and so on. So it is Kubernetes that has these, what I call runtime controllers, that complete the picture. Now, the real magic happens when we start to draw together all of these different reconcilers, all of these different controllers across this entire spectrum. Now, all right, so Kubernetes has these runtime controllers, but as I suggested earlier, Kubernetes isn't just about runtime controllers for pods. It's actually a platform for reconciliation loops. So what if you want different deployment behavior? For example, what can you do with that? Well, what if you want canary style rolling upgrades? What if you want blue-green? What if you want A/B testing, where you're actually going to run both two versions of something in parallel and actually use the metrics coming out of those to make decisions on, who gets what and where the traffic goes. So different deployment scenarios. How does that work? Well, what you can do is, you guessed it, you can have a reconciler. Kubernetes allows you to extend the API. So you can create a reconciler that, for example, recognizes when a deployment is happening and provide some additional logic on top of that. Now, as it happens, one of the projects that we have worked on here at Weaveworks is a project called Flagger. It is totally open source, and it does exactly that. It allows you to define a deployment strategy, progressive delivery, as James Governor had coined that term. And it allows you to select one of these release strategies, canaries, A/B testing, blue-green, and then it interfaces with ingress, either kind of plain vanilla ingress like an Nginx or a service mesh, and it interfaces with the ingress or the service mesh to do the traffic routing to provide exactly those types of release strategies that you're going for. And how is that implemented? Of course, it is implemented as a set of controllers that run in the Kubernetes. This project is open source. You can find it there at the URL, and I won't go more into the details, but what you can see there, and really the point that I'm getting to, is that not only are we going to leverage the runtime controllers that are in Kubernetes, we can also extend things with the runtime controllers ourselves. Okay, that's a lot. If we go back to this picture that I just showed you a moment ago, there's reconcilers all over this. How can I possibly manage that? Well, the first thing that I want to show you is that, in fact, this is a version of the very first, very simple diagram that I started with at the beginning of the presentation. Let me show that to you again. We've got something, we're storing some declarative configuration in Git. Then we have a set of delivery controllers that facilitate the delivery with whatever the pipeline is I want into etcd. Then I have a set of runtime controllers that actually achieve getting that running in production. Remember, that is, we store code and configuration, we've got automation, and we've got a runtime environment. Oh, and of course, the user interface for this entire system is all the way on the left-hand side with Git. So it is, if you will, that very simple picture that I showed at the beginning. But hopefully you're getting the idea now that the way that we do that automation in the middle has to be cloud native. Cloud native operations is what GitOps is all about. Let me kind of put a bow on this now. I like to think of GitOps as this, those set of delivery controllers. And the delivery controllers, I haven't been referring to them by name, but some of the ones that I referred to earlier in our derivation were things like that we call the source controller, or the customized controller, or the image update automation controller. On the runtime side, we have the ones that are baked into Kubernetes, like the replica set controller, or the daemon set controller, or Flagger is an extended controller. And yes, cluster API controllers, those cluster API and GitOps match made in heaven. They work beautifully together. So you take those controllers and then you stitch them together into the pipelines that are relevant for your organization and for your needs. And that's what draws together GitOps. So to go back to this picture, we've now completed this entire cycle. We've got continuous integration on the far left. We talked about the delivery controllers. We added on the runtime controllers, and you draw all of that together and you get GitOps. So GitOps is not just about delivery. It is, in fact, GitOps is the combination of continuous delivery, delivery controllers, and continuous operations runtime controllers. And when you put those things together, that's where a lot of magic happens. Now, I had promised you that we were going to derive principles. We were going to go back to first principles. So oftentimes, when I've spoken about GitOps in the past, I've started by presenting these principles. But today, the whole idea was to kind of maybe challenge your assumptions on what GitOps is and to derive those principles from scratch. But let me now summarize and review those principles that we've just gone over. I'm going to start with the bookends. On the left-hand side, we have declarative configuration. That's YAML, for example. On the right-hand side, we have the software agents. So the deployment controllers, for example, deployment replica set. These are two foundational principles that Kubernetes brought to the party. Without those two foundational principles, we wouldn't have GitOps as we have it today. That really seeded the ability to get this started. So we have those two bookends. And what we've done with GitOps is we've added two more elements in the middle. We've said, well, if I've got that declarative configuration, and I now add storing that declarative configuration in a version controlled, immutable store that has semantics like Git, then I achieve those benefits of things like roll forward rather than roll back. I can always get back to an earlier configuration that I know worked. Or if I have a disaster, I can recover from that disaster very quickly. So that is another magical element. Now, yes, I also alluded and mentioned several times that it is the user interface. It doesn't have to be the user interface. And there are some very interesting other user experiences that don't involve necessarily going in and creating a pull request by hand. But some of those abstractions, those Git semantics, are important and very, very heavily leveraged. So I like to say that Git plays the role of both a potential user experience as well as a distributed data store that is immutable and has a version history. And then finally, the third thing, the third column over there, is that we have this set of delivery controllers that automatically apply, but that allow me to build the pipelines that I need to apply those patterns in the entire GitOps practice. And that's what we've done, is we've just derived those 4 key GitOps principles. Now, I won't go over this in detail, but you've heard me talk about these GitOps patterns, or as I also like to call them, cloud-native operational patterns. Over the years, as we got better and better at microservice architectures, we learned a whole suite of patterns that were those cloud-native patterns. And in fact, that's what I cover in my book. Things like retries and circuit breakers and service discovery and those types of things. What we're doing now with cloud-native operations and with GitOps is that we are deriving these sets of patterns that are going to become ubiquitous in the coming years and going to be applied for great gain. So with that, I thank you for your attention, and I hope you enjoy the rest of the conference. Thank you so much. Have a great time.